Hello everyone, welcome to my YouTube channel IndiaGATE. This is Nandani Sharma. In this session of the Discrete Mathematics, we talk about set and type of sets. So, before starting of this session, if you are watching first time my video, so please subscribe and click on bell icon for all notification of my new videos. So keep on like, subscribe, sharing and comment on my videos. So let's start. Set. So what is a set? Set is a unordered collection of objects. Here, object in a set is called element or member of a set. Means any set is represented as capital letter like here capital A. So, small a is the element of set A. Also, we say that small a is not an element of set. Some important sets like natural number, integers, positive integer, rational numbers. Means here natural number represents 0, 1, 2 and so on. This is including all type of integers, and z is equal, where integer is positive and negative both are included. Here positive integer contains only positive sets, and in rational numbers here it is type of p upon q such that p belongs to z, means your positive integers and also negative integers q also belong to your integers, and q is not equivalent to 0. This is called your rational number. Now here R is a set of real numbers. Real numbers means it is also include all type of integers like 0, 1, 2, 3, 4 and so on. Now move on to your equal. Means if two sets are equal, if and only if they have same elements, we write as A equivalent to B if and only if B are equal set. A and B are equal set. Means here this is represent like this expression. Now move on. So a set that no element is called empty or null set. Null set. Here phi is represent as null set. Also empty curly braces, inside a curly braces is called your empty set. Singleton set. Singleton set is your a set only one element, means it contain only one element or alphabet is called your singleton set. Subset. A set A is said to be subset of B if and only if A is also the element of B. So we say that A is a subset of B if and only for all x belong to A implies x belong to B. Means x is the element of A, also B. For set as we say that first one is phi is always belong to any set of elements, and any set is also subset of itself, means S is a subset of S. Important point is that phi is not belonging to 0, 1, 2, 3, but phi is belong to phi null 0, 1, 2, and phi is proper set of 0, 1, 2, 3. Now come to the what is a proper set. So proper set, if a set A is a subset of set B but A is not equivalent to B, that A is a proper subset of B for all if and only if x is belong to A implies x belong to B, and there exists x is belong to B and x is not belong to A is true. So it is your called proper set. Now move on an infinite set. So a set S have a exactly n distinct element where n is a non-negative integer is called your finite set. Here n is a cardinality of S. Cardinality of S is denoted by mod S. Now a set is said to be infinite if and only it is not finite, means it is also include negative plus positive integers. Now move on. Next, power set. Power set, a given set S is a power set of S or all subset of the set S, means set of S is denoted by P of S, and if a set has an element, then its power set has 2 to power of n elements, means if a set A equivalent to 1, 2, then power set P of A is equivalent to 2 to power of 2, means equal to 4 power set. So this is not your power set. Now move on. Next, important order and tuples. So ordered and tuple is represent like A1, A2, so on an times is the order collections like similar type of elements. This element A2 is where A1 is your first element, A2 is your second element, An is your nth element. Two ordered tuples are equal if and only if each corresponding pair of their element is equal. So, two tuples are called ordered pair. Example, A, B is your ordered pair. Now move on, Cartesian products. So Cartesian product of a set A1, A2 ... n times denoted by A1 Cartesian, A2 Cartesian, A3 and so on an times is a set of order n tuples. N tuples is represented like A1, A2 and so on an times, where AI is belong to capital AI, where capital AI is your set. Now Cartesian of A1, A2 ... an time equivalent to A1, A2 an times, such that AI is belong to capital AI for AI equivalent to 1 to n at time, or Cartesian product A Cartesian B equivalent to A comma B, such that A belong to capital A and B belong to capital B. Now using some notation with quantifiers. So first one is your for all x belong to S, P of x. It is a shorthand for all x is belong to capital S and implies P of x, and there exist x belong to S, P of x. So we know that existential quantifier is closed under the conjunction, and your universal quantifier is closed under the conditional statement. So we say that this is written like this. Now here important things that A Cartesian phi and phi Cartesian A is always null, means phi. Now move on, set of quantifiers. So truth set of quantifier is represented like that using of predicates P and domain D. Truth set of P is a set of element x in domain D for which P of x is true. The true of the P of x denoted by x belong to D, such that P of x For all x, P of x is true over the domain U, where U represent your universal set. So, if and only if truth table of P is U, there exists x, P of x is true over the domain U if and only if set of P is non-empty. Set operation is your union, intersection, difference, and others are included. So in a union, it is collection of all type of elements used in set A, B, and so on. So here A union B equivalent to X, where X is belong to A, or X is also belong to B, means it is a combination of set A and set B, or set B, means it is combination of set A or set B. Now move on, intersection operation. It is common part of A and B is represent, means A intersection B equivalent to X such that X belong to A and X belong to B. Difference. The difference of set A and B denoted by A minus B. It is set containing those elements that are A but not in B. The difference set A and B is also called complement of B with respect to A. So, A difference B is equivalent to X such that X belong to A and X is not belong to B, because here it is represented, means element is in A but not in B. Complement operation. So here U is represented as universal set. So complement of set denoted by A bar is a complement of A with respect to union. So A complement is equivalent to A minus U minus A, or A complement is also represent like X such that X is not belong to A, means it is belong to U. Two sets are called disjoint if and their intersection is empty set. Set identities. This set identities is based on some important rules and law. So start from first rule or law is your identity law. So identity law is represent like A union null equivalent to A. A intersection union equivalent to A, means it represent your elements itself. So it is called identity law. Now come to the domination law. Domination law is represent like if B union with any set universal, so it represent universal set, and when we intersecting any element with null set, so we got null set itself. It is called a domination law. Now move next law is your idempotent law. Idempotent law is represent as if we intersect or union any element with itself, it is represent that element. So it is implies like idempotent law. Now come to the complementation law. So complementation law is represent like your double complement of any element is your represent that elements, means double complement of A is equivalent to A. Now move on next commutative law. Commutative law is represent like A union B equivalent to B union A, A intersection B equivalent to B intersection A, means interchanging the positioning of A and B is represent your commutative law. Now comes to associative law. So associative law is also easy. Here bracket is used to represent the separation of the operations and priorities. So basis of the braces, and this is represented like this: A union in braces B union C equivalent to A union B in braces union C. So this is represent your associativity. Distributive law. This law is represented like this: A intersection in braces B union C equivalent to A intersection B or A intersection C, and also A union B intersection C is represented like A union B and A union C. Now next rule is your De Morgan's law. De Morgan's law is represented like if the complement of the any intersection or union operation we got like complement with interchanging the operators. So we got that after the applying the complement of A union B is equivalent to A complement and B complement. Also after the applying complement of A intersection B, so we got A complement union B complement. So it is represent your De Morgan's law. Now comes to the absorption law. Absorption law is basis of the just taking the symbol, taking a starting symbol is same, then it is your represent a element. Here the repetition of a set is 2 times, so it is your equivalent to A. So it is represent your absorption law. Now move on. Next law is your complement law. If B A union A complement, so it is represent your union set, and when B A intersect with A complement, so it represent your phi set, means this is represent your complement law with union and intersection operation. Now move on. Next topic is your symmetric difference. So symmetric difference of A and B denoted by A XOR B. So here this symbol is also says your symmetric difference containing either A or B but not both A and B, means A symmetric difference is equivalent to A union B minus A intersection B or A minus B union B minus C. So hence we say that the using of associative law, we say that A symmetric difference in braces B symmetric difference to C equivalent to A symmetric section B plus symmetric difference C. And here I hope you understand all the points. Thank you. Have a nice day.